Hello learners, you are very welcome to yet another physics class. My name is Bieko Semakula Samuel. I'm a teacher of physics. In this class, we are going to demonstrate an experiment to determine relative density of a solid using Archimedes Principle. Now, relative density is the ratio of density of an object to the density of water. Now, we can derive something from that. It is also equal to the weight of an object divided by weight of equal volume of water. And that is where Archimedes' principle comes in. The apparatus that we are going to use, we have our specimen. We are going to get the relative density of this stone. We shall be using spring balance to measure the weight. We have a beaker here which has water in which we shall immerse the stone. As a highlight, we are going to determine the weight of the stone when it is in air, which will be the actual weight of the stone. And then we shall determine the weight of this stone when it is fully immersed in water. Step 1, we shall determine the weight of our stone in air. So we suspend it on the spring balance and we take the reading from the Newton scale of the spring balance. Reading here is 0.60 newtons. Step 2, we need to get the weight of this stone when it is fully immersed in water. So we bring our source of our beaker of water and we are going to gently lower this stone into the water. Careful that the stone does not touch the sides and careful that it is fully immersed without touching the bottom of the beaker. The stone should be freely suspended in the beaker of water. Free, suspended, and totally immersed. So there we have our stone completely immersed in water and freely suspended. We then take the reading of the weight of the stone when fully submerged from the Newton scale of the spring balance. The reading of the weight is 0.35 newtons. The relative density of this stone is equal to the weight of the stone in air divided by the upthrust in water. The upthrust in water is obtained from the difference between the weight of the stone in air and the weight when it is fully submerged in water. Now, we obtain the weight of the stone in air as 0.60 newtons and the weight of the stone when fully submerged in water as 0.35 newtons. Therefore, the upthrust on this stone in water is 0.60 minus 0.35 and that gives us 0.25 newtons. So the relative density will equal to 0.60 divided by 0.25. That is the weight in air divided by the upthrust in water. And that value, when you check in your calculator, is 2.4. So the relative density of this stone is 2.4. We know that relative density is equal to the density of the substance divided by the density of water. So to obtain the density of the substance, we shall have relative density times the density of water. Knowing the density of water as 1 gram per cubic centimeter, so 2.4 times 1 gram per cubic centimeter will give us 2.4 grams per cubic centimeter. So the density of this stone is 2.4 grams per cubic centimeter. If we convert it to SI units, we shall have 2.4 times 1,000, which is 2,400 kilograms per meter cubed.